Interesting question. The question was, do we have to draw graphs today? And for the first half, like while we're doing it, yes, by hand. And then the assignment is actually on Delta Math. And I went back and forth when preparing for you guys today. And I finally settled on, let's do them by hand. Let's learn how to do all the subdivisions and the breaks. And then when you go to do it in Delta Math today, you'll find it to be more pleasant, I think. Delta's got a little bit less to ask of you than I do. So, but if we do it my way first, then when it comes time to actually do like a quiz or something, then you'll know what to do. So
No holes for Lauren. Yeah. Tea bottoms and a coconut broth and a leg and a horn. So, oh, no.
So this is what we're doing today. We're not going to move the graphs sideways today. That's called a phase shift. That'll be probably tomorrow, maybe Wednesday, maybe Thursday. So let's see how today goes. I don't think you're going to struggle with this today. What's going to happen today is all the things you've already learned with moving the midline up and down, pulling the amplitude up and down. Those things are going to continue with this. What the third guy, though, the third transformation today is we're going to take the period and we're going to make it longer or we're going to make it shorter. How long is a current period for either a sine or a cosine? No, what I mean by that, like, is how many radians does it take for one cycle of sine? I heard it, but it was a whisper, and I'm not sure because did you say 2 pi? Yeah, good. Sorry, the AC is going on. I can't hear when you. So yeah, 2 pi is a period, is what we say. So and there are other trig functions, tangent, and I think it's just tangent. Tangent has a period of pi, but I think we're not probably going to graph tangent at this point in the year. I think we're going to do the sine and cosine, move on to some other stuff, and then maybe we'll come back in April and May if we have time. But anyways, tangent has a different period, but sine and cosine all have periods of 2 pi. Our job for today is to start taking that 2 pi and making it stretch and take longer. So like we might have a period today for one sine curve that might to you still look the same, but it takes 0 to 8 pi to get it done, or it might take 0 to pi over 8, believe it or not. So you can stretch periods and you can compress periods. So the new kid on the block today is, you'll see him, I hope, right away, is the 2. And I've been trying to avoid writing y equals a times sine of bx minus c plus d. And I'm still going to avoid writing it down. But just know that eventually I'm going to put an equation up here that has 4 variables in it, 4 numbers that can change. And you've seen a number that goes here. What is, if I put a number where that arrow is pointing, what does that affect? Say,
that's your multiplier.
That's your amplitude. Thank you. Very good. That's how far away from the midline gets. So that's your amplitude modifier. We've seen that before. And you've also seen what happens when we put a number at the end. That's your new midline, right? So like if it says -4, then the whole graph just literally shifts down and revolves around a line that sits 4 units down. So these are the 2 things to this point that we've played with. There are, though, 2 other modifiers that now come into play. And so don't be confused by this 2 and a 2 that would be in front. If the 2 were in front, then we wouldn't be talking about this. It would just be a sine curve with a stretchy amplitude, easy peasy. But what happens when the 2 is there is it affects this part. I've tried to say it in my head 10 times, and I've decided that no matter how many times I practice the words, it won't come out right. Putting a number attached to x affects how much x you need to complete a cycle. So, for example, if I said to you that, and I don't know if you want to write this part down or not. Like, I don't think that I would, but if I told you that X, and by the way, I'm switching from theta to X as of today, just because then it's going to play nicer, because we're going to be doing quite a few assignments on delta math, and delta uses X. So just FYI. So back to X axis, Y axis. So if I told you that X was pi, remember, pi, only pi. That's not a full 2 pi. That's a pi. But if I put that pi right there, what's 2 times pi? Yes. So what's happening here, and this part could lose you, and the lesson will still go fine, just for the record. But if you put pi in place of X and then you multiply it by 2, you realize, hold on a second, my X value is only pi, but I'm actually evaluating the sine of 2 pi. Then what is the sine of 2 pi? Correct. So what's happening here is I need, how am I going to say this? I need less X to accomplish the same task. Like if I want to go all the way around the unit circle, I can get it done with only 1 pi, because when I put pi in there and multiply it by 2, it actually doubles the output, if you will. And I say there's a very high chance that that made absolutely no sense. But by putting a number multiplied by X, it affects how much X you need to get a job done. There will be cases when you need more X to get a job done. You'll see that in example 2. And there are times when you need less X to get the same job done. And that's example 1 here. So let's get to it. The question becomes really for today, what is the new period? And the period is obtained very simply. And just, we're going to call this number, I'm sorry, but we're going to call him B. And the reason I want to do that is because eventually, starting here in the next couple of days, I am going to put the big Y equals A sine of BX plus C plus D thing out there. And I just don't want you to be freaked out when it happens. So for today, the number that's multiplied by X, his new name is B. And so to find the period of a modified function, you just take its normal period, 2 pi, and you divide it by B, which means in this case, we divide the normal period of 2 pi by 2, and we now get a new period of pi. So what this means for us is that now when we graph our new sine curve, the period is going to only be half as long. And so when you graph, I don't want red, I want white. When you graph normally, as you have been, how far out have we been going when we make our first mark? Correct. And I'm only going to go to pi. And what's going to happen now is that because the period has been shrunken to 1 pi, the graph is going to complete a full cycle from 0 to pi. It's going to undergo all of the same ups, downs, and backups. But now what I have to do is I have to create the 4 subdivisions. And this math is easy on this problem, but it will get harder in some. So when we get to one that's a little tougher, I'll give you a little more guidance. But in this case, I think it's obvious. Sorry, I don't mean to make you feel dumb, but what's half of pi? Good. So we know that pi over 2 is the halfway. And it didn't used to be this way. The halfway point used to be pi, right? What's half of pi over 2? And then what's halfway between pi over 2 and pi? Correct. 3 pi over 4, right? And so what we have now is we have a full cycle that takes place between 0 and pi, as opposed to 0 and 2 pi. So I'm going to make a mark up here at 1. I'm going to make another mark down here at -1. And just out of habit, I'll draw in my, oops, that I should have used my line tool for that. I apologize. I'll draw in my lower capper and my upper capper. And now we're going to repeat. The good news is once we're really good at graphing, which I hope when I look at these quizzes from yesterday that I see you've got this down pat. Once we understand fundamentally how a function behaves, all the structural stuff is in place. Like the infrastructure is there. Now I just need to attach the dots. So where does sine start? Yeah, on the midline, right? And then where does he go? He goes up, he comes back to the midline, he goes down, and he comes back to the midline. So the mathematics of it isn't really that intensive. Like once we've done the legwork ahead of time, And it's the math, like I said, can be more difficult sometimes than others. I mean, dividing 2 pi by 2 is pretty fourth grady, right? And then cutting pi in half and then cutting that in half is pretty, what, sixth grady. So the math in this case wasn't really intensive at all. And once you get the math done and the structure in place, then you just attach the dots and you've got yourself a curve. And the only reason someone would have to know that this graph is any different is because they would come in and look at my scale. Like if I didn't label my x-axis with pi over 4, pi over 2, 3 pi over 4, blah, 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 then no one would know that we have a modified sine curve here, right? But it's the labels that are the key. So for you guys whose graphs are sucking some serious bootay, a trick you can use is to try to accentuate. So what you guys like to do is try to connect the dots quite literally very straight. And so rather than coming at them straight, try to think of it as like, I'm going to go up pretty steep and then allow curvature to happen. Allowing that curvature to happen is really where a lot of the goodness can come from. So you see how I've kind of purposely bowed it up and out. And then when I come down to pi over 2, I'm going to continue on straight and then I'm going to curve it down. And again, your guys' natural predisposition is to want to just do something like this because you haven't practiced enough, perhaps. But eventually, you want to sort of bulge those curves out, and that's what it forces you to make. You can't, like if I come down here like this, I am now forced to make curvature. I can't go, I've got to curve back to make contact again. And then I'm going to curve again and come up like this. And then I'm going to see another curve like that. So I'm going to try to not be like super picky or mean about it right now, but I just want that to be something as we go that you guys continue to work on. Because I say they were a little rough to look at. So anyways, there it is. That's a sine curve that you would not even know was modified unless you either saw the equation or unless you saw the labels on the axis. Any questions about that? Okay. And don't worry, like tomorrow's probably going to wind up being a pretty heavy work day because I think these examples are going to wind up taking a little longer than I thought. So, and then I want to show you how to do it on Delta Math too. So next one is this. And by the way, I will sometimes, out of habit, because I'm kind of old school, I feel better when I put the entire argument of my function in parentheses. You will not see the parentheses when you do work like today or tomorrow, whenever we get to it on Delta Math. I feel better when I have my whole argument enclosed. So don't be confused if you see it. Some, like I do it sometimes, some books do it, some professors might do it, some professors might not. I just feel better when I enclose my argument like that. I just like to say it's the cosine of all of that. And I get, that's, I guess, implied without them, but I just feel better. So in case you were inclined to ask, if I go back and forth between having them and not having them, it's just a thing. No big deal. All right, so this is a cosine curve. What's its period going to be?
Pi over 2 divided by 1/2.
It's exactly that. And I want to say again, and the first time it rarely makes sense. This is the second coat of paint example where something, hopefully light bulb kind of goes on, something clicks. Remember this number right here that I'm pointing at, we're going to call B. And to find the periods as we go through today and probably the next week or so, you're always going to take the default period 2 pi, just quite literally divide it by B. And if I take 2 pi and I divide it by B, which is 1/2, then I go into survival mode here, copy dot flop, right? What is 2 pi divided by 1 over 2?
I got 2 pi over 2.
It is not that. It is 2 pi times 2 over 1. Remember that when you divide by a fraction, you have to copy dot flop, which means to multiply by the reciprocal. Do you remember this? Why did I put this 1 right here?
Because it's a whole number, but yeah.
Right. So I just put that, the one I circled in yellow, I just put there because I wanted to have something to show you guys that 2 pi is really a top 2 pi over 1. And then when I copy dot flop, I see, oh, the 1 and the 2 switch places. And let me ask you again now, what is the new period? It is. So interestingly enough, what we just learned in the last like 8 minutes is that if I put a whole number in front of X, my period shrinks. If I put a number less than 1 in place in front of X, my period actually grows. And that's going to be counterintuitive to what the human brain would tell you. A normal person would say if it's smaller than 1, it shrinks, and it's backwards at that. When you divide by small numbers, you get bigger. So in this case, now we have a period that's actually longer. And so again, the same thing takes place. The period this time accomplishes half as much. No, I didn't say that right. The trig function accomplishes half as much because of the multiplication by a half. It says, I'm going to keep gutting you by a half. And so if I put like, follow the purple arrow, then I'm going to answer your question. If right there, if I put what normally would be a full period cycle, if I put in 2 pi, that normally completes a cycle, right? But what's half times 2 pi? What's half of 2 pi? 1 pi. And then I realized, dang it, I just put in what normally would be a full workload around the unit circle, and I only got halfway there, which implies, oh, so I need to go essentially twice to get the same bang for the buck. What was your question?
My question is if the x was always going to be 2 pi.
For now, yes. And I said that earlier, but now you're ready to hear this. Not all trig functions have a period of 2 pi, but for your near future, this class, yes. Our periods are going to be 2 pi's. Because that's what sine and cosine both have. They're periodic functions that repeat themselves every 2 pi, right? So for us, yes. And I say, I don't think we're going to do any tangent graphing right this sec. So far, so good. And so the graphing, you guessed it, isn't going to be all that complex. We're just going to make our axes. And then this time, what's my far right number? 4 pi. But structurally, it's the same. I go halvesies, and my artist formerly known as the endpoint is now the midpoint. And what's half of 2 pi? What's halfway between 2 pi and 4 pi? And so we structure. We've got our x-axis built. We're going to find our midline. We're going to find our capper lines. And for these first 2 examples, I made a very conscious choice to not do anything with midline or amplitude. So again, we're just going to have a capper line here, bottom capper line here. And then this is just a normal cosine function. Where will it start? We'll start high, right? Cosine starts high, and there's no modifier to tell me to go low. So cosine starts high, and then he follows the pattern. No math necessary. You go boom, 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 and then try to make it not look like doo-doo. Questions so far? Because I'm going to ramp it up on this next one. Okay. I'm not going to connect those dots. That's, you guys are good. You get that. Just got to work on it. That's all. So our next one is y equals 7 times the sine of 3/2 of x plus 1. So there are 3 characters at play now. There's everything that I want you to know how to do. There's the period adjuster. We know that he's located next to x. There's our amplitude modifier in the front, and then there's our midline adjuster in the back. So the first thing I would always do, and this is the way, so like when I write these down, I'm going to try to set a good example for you here. The first thing I'm going to do, I'll switch colors over here, is I write down what the midline is. I found this to be useful for myself. So I go off to the side and I say the midline is at y equals 1. Good. So that means that when we go to make our midline, we know to go up 1. And that's just the number at the back, right? That's the guy you're going to come to know and love as D. D is your midline guide. And then I also want to know what's my max and what's my min. What's my max? It's 8. Because if our midline already starts up 1 and the amplitude is 7, we go 7 above the midline to get to 8. And then what's the min? It is -6. Because if we go 7 units away in the downward direction, we drop. And so that helps me right away to build that highway of those 3 lines: midline, top line, bottom line. I would always do those 3 things first just to get them in writing so I know what to do later. Now comes the new part for today, and it's this guy, the period. And for now, I'm going to write period equals blank. Like I'm not going to put anything there. What is the mathematics that I have to do to calculate the period?
You gotta do
2 pi over.
2 pi divided by 3/2. Very good. Right? Just faithful every time, 2 pi divided by b, whatever b is. And then the copy dot flop last time was a little bit rough. You guys should see it now with clarity. Really, I sometimes wouldn't even write that. Like I wouldn't have even written 2 pi divided by 3/2. I would have just written 2 pi times 2/3. Right? Good. What is 2 pi over 1 times 2/3? So we now have a period of 4 pi over 3. The next 4 minutes are the part of this lesson that you won't like. Some of you won't, it won't bother you. Some of you, this won't be the good part for you because we have to do some math, some arithmetic. And if the next part of the lesson doesn't bother you, thank someone who taught you good basic skills. Probably wasn't me. So just thank whoever that was. Go home tonight and give them a hug and say thank you. Or if it's an old elementary teacher, give them a call, send them a postcard, something. So we have everything now that we need to make the graph. We understand the stretch. We know the midline. We know the cappers. We know the period. So let's get to it. So we're going to make our structure. Got this. And because I feel like I think my graph's going to be slightly skewed maybe to the north, so I'll give it a little more loving on the north side up there. What number is going to go right here? 4 pi over 3. Now, this is the basic skills portion that I remember having taught this years ago, that this is unfortunately where some people get hung up. So just speak up if you need some clarification. What's half of 4 pi over 3? It is 2 pi over 3. And there are people that right away turn this into a math problem and they turn it into this, oh God, what just happened? But if you think about, like, if I had something in my pocket called a pi over 3 and I took them out and I was like, oh, thank goodness I have 4 pi's over 3. And I said, let's take half of them. Don't make a math problem out of this, right? It's just now I have 2 pi over 3, correct? And there will be instances in which that doesn't work. If I have an odd number of those, then that'll be a discussion that we have. Okay. But for now, just take half of the top and you take half of a fraction. And what's half of 2 pi over 3? Correct. And then, of course, what's halfway between 2 pi over 3 and 4 pi over 3? Pi. Very good. So that's the mathematics portion, and that can get a little bit hairy when the numbers are a little bit maybe more like mean and toothy. Okay. So let's go build our highway. And again, I'm not going to focus for me now. Delta math will care, but I'm not going to worry too much about the scaling aspect of it. So my midline is at y equals 1. So I'm just going to make a mark here at like, and this one I can actually probably scale pretty well. So I'm going to do a 1 here. And I'm going to draw in my midline. So I've been trying to be consistent with my colors. I'm going to use green. Gosh darn, forgetting the line tool. I'm going to use green for my midline. And then where do I need to make 2 more numeric marks? Yeah, so I need to go up here to 8, make a mark, and then I'll go down here. I'll try to just eyeball this like -6, something like that. So you don't have to put all the ticks and count it all out and stuff like that. So we're just going to go up to 8 and make a capper. If there's a better name for those lines, you should tell me what you think it is, because I don't like, I think capper sounds stupid, but whatever you want to call them. Boundary lines, maybe would be better. I don't know. So there it is. The infrastructure is all in place. The math has been done. And now we're right back to just, can I graph a function? It's a normal sine, right? It's not a reflected. Where will it start? It'll start on the midline. So stop saying 0, because remember the midline is rarely actually going to stay at 0. So we're going to go to the midline to start our sine curve. And where does it go? It goes up because it's not reflected, and then it comes back to the midline, and then it goes to the bottom, and then it comes back to midline, and there's your sine curve. Still good? Do you guys need a 2-minute break? 1-minute break? You want to just plow on? We good? We're good? Okay, let's press on. Any questions so far? let's do. I'm going to call an audible here and skip one of my examples because the clock's telling me that I should try to get through two more, and 3 is a little ambitious. So I'm gonna murder the fourth example, and we're gonna do examples 5 and 6 instead. So here it goes, and I'll come back to it if time permits. So we are going to graph y equals -4 times the sine of 2/5 of x plus 3. You don't have to follow all my little pro tips. You probably trust me by now and generally know that I'm not just making this up as I go. But what's the first thing I had suggested that maybe we write down?
Midline.
Yeah, good idea. So let's write down where the midline's going to be. And if you don't need this kind of stuff, that's okay. The midline is at where? At a boy, y equals 3. Okay, so that's a horizontal line at 3. And then we're going to need to do a max and a min. How high up is the max going to be? Good job. 4 away from the midline. And then how low is the min going to be? -1. Important structure. I mean, already I feel like I could start making the graph, right? Build the highway with the 3 lines. The last one is the period. So over here, I'm going to calculate my period, I'm going to do 2 pi. Watch this. Divided by 2/5. You guys cool with that? So that's what I had sort of hinted at last time, is that if you know you're just going to flip it over, just cut right to the chase, multiply by the reciprocal. You don't have to put the 1. What is this going to wind up being for a full, bless you? What's this going to be for a period? Right. Good. So we have everything now that we need. The question now becomes, we have to do some math, right? We have to find those intermediary ticks. And the math of it is really just division by 4. So I kind of like to build the structure of the graph first and then go back and worry about the numbers. So again, I'm going to try to be mindful of where most of my action's taking place. And I feel like most of it takes place up above. So that seems like a safe graph there. Furthest mark to the right is what x value? There you go. And now come the subdivisions. And I don't think you'll struggle with this. What's halfway between?
5 pi over 2.
5 pi over 2. It's a great way to say that, right? So 5 pi over 2 is what I'm going to put. What's halfway between 0 and 5 pi over 2? This is what I talked about earlier. And if you're still listening, I just love you guys for that. You're amazing. Yes. So sometimes, listen, if the top number of a fraction's even and someone says take half of it, you're like, well, duh, I'll just take half of the top. But when that's not on the table, because you can't take half of 5, if you want to take half of a fraction that has an odd top, double the bottom, it accomplishes the same thing. So taking half of 5 pi over 2 is really just making it into 5 pi over 4. Is that okay with you? Now, this one can be tricky. What's halfway between? I always remember now, it's coming back to me. This is the part that I got yelled at for a lot. What's halfway between 5 pi over 2 and 5 pi?
And pi over.
Now, 10 pi over 4 would just be another 5 pi over 2. Here's the scoop. This is what I think. There's another mathy way to do this, but I'll show you what I would do. I would understand now, and you would too, I hope. I don't want to move on till you do. Would you agree that that thing that I just highlighted in red is a fundamental building block of this whole thing? That it takes one of them to build this and another one to build this and another one to build this. So if you want to know what's halfway in between here, take the starting point, 5 pi over 2, and add that fundamental building block of 5 pi over 4. Okay? And then, of course, now we go back to like 5th grade. What do we have to do when we add fractions together? Common denominator. Sound familiar? So this is actually 10 pi over 4 plus 5 pi over 4, which officially makes this now 15 pi over 4. That's the part you hate. You don't have to say it out loud. I just saw two expressions on people's faces that made it very clear that that was it. There's the demon part. There's another mathy way to do it, and it's just finding an average. I don't think you want to see that one right now. No. How about this? Okay, for you people who made the dirty face at me, let's go back to this. It wasn't really actually dirty. It was just a little bit like, what just happened? So do you remember how we found 5 pi over 2? And then do you remember how we found 5 pi over 4? Look at this. You can just count by pi over 4s or by 5 pi over 4s. Man, I hope this doesn't lose you even worse. So you have 5 pi over 4, add another 5 pi over 4. What do you get? You get 10 pi over 4, which of course reduces to, I bet you like this way better, huh? And then add another 5 pi over 4 to that. What do you get? Did you like that way better? Better? Okay, good. Anyhow, that's the sucky poopy part is you got to find those 4 markers. And so, yeah, there's some math involved. So anyhow, whatever method you use, make sure that you're able to get those ticks in there. So, and then from here, business as usual, my midline is going to be up at 3. So I'm going to go up to 3. And then my max line is up at 7. Go like another 4 up here, 7. And then my min is down here at negative like 1. And then I'll draw on my lines and make my graph. I really feel at this point like the graph probably needs going over, but let's just get this done and make it official, right? What am I doing? I am. Yes, very good, Cooper. I just got to get my structure, but you're exactly right. This is going to be a downwards graph because it's a reversed sine. And I would, of course, take points off my own paper right now because I don't have my y-axis labeled. So I need to put a 7 on this one and a -1, and now we're good to go. So yeah, it's a sine curve, and it does start at the midline, but like Coop said, it starts its travels downwards because it's a reverser. So it heads down to the base, back to the midline, up to the max, and back to the midline, like such. And then again, I'll leave the artistic endeavors to you guys. One more. Got it in you? And then time willing, I would like to show you quickly how the delta math works. I'm just, before you yell at me and get all bent out of shape, you do not need those 3 numbers and the yellow oval for delta math, but you will need them for me. So this way here, we're getting this out of the way, and then we go and do delta math where we don't need them. And we're like, oh, this is great. And then you come back to mean old Mr. Ahern's paper assignments and you got to do them again. So at least you know already how to do them. Okay. All right, last example. And by the way, delta has a feature when we get to it. Let me see if I can just make this quick. Over here in delta math, this is what the graphs will look like. And I know you probably, I'll try to zoom in a minute when we do it together, but you can set scales. So like if I want my y-axis to go by like 5s, which I would in this case probably, then I can just type that in there and it'll set to go 5, 10, 15, 20. Because you will have to do that. You can't get through some of the problems if you don't. Because like we obviously can't go down to -25. So anyhow, let's get to it. What are we going to find first? Midline, and midline is at what? So y equals -25. Very good. And after that, we want to know the maximum. And where's the max at? -20. Good job. And then where's the min? Nice. And then comes the period. So to find the period, we are going to go 2 pi, and I'm going to write this one out, divided by pi over 2. So just have faith in the system here. When we divide by b, we actually have to flip b over and multiply, right? So this is going to be 2 pi over 1 times 2 over pi. What do you notice? Say again? Yeah, and these pi's actually cancel. So the period of this function is actually just 4. And I know the first time that ever happened to me, I was like, I cried BS, like, wait, this is a bunch of crap. You always told me the period is like pi over 6 or 9 pi, and then suddenly you just give me a dang number. Just understand, please, that pi is a number. Pi is 3.14, blah, blah. 2 pi is 6.28, blah, blah, blah. 4 is also just a number. It happens in this case to not be expressed in terms of pi. Clear? So if the period winds up being just a non-pi number, so be it. Think about how easy this is going to make, how third grade easy this is going to make it to label our x-axis here in a second. If you haven't picked up what I'm putting down here yet, well, just get in there and take a look. You'll be probably entertained by it. The mid, all my action is going to be happening down south. So I'm going to draw all my, it ought to just look like this, really. So what's the furthest right tick mark? 4. What's halfway between 0 and 4? 2. Smarty pants. What's halfway between 0 and 2? 1. And halfway between 2 and 4 is 3. And that is odd until you just accept it and then you go. Remember, pi is just a number 2. Just happens to be a very specific irrational number. Okay. So I wanted to make sure we got one of those in the notes so that you didn't freak out when you saw it. But business as usual at this point, you're going to go down, you're going to draw your midline, and again, just mark what you need, quite frankly. So on paper, I would go down to my midline that's at negative 25. And then I have a lower at negative 30 and a 1 right above it at negative 20. Scaling, don't worry about it. And then you just do your thing. I'd like to just hop over. Is it okay if I just don't formally finish this? You get it right. What kind of graph is it? Actually, let me do the dots and then I'll move on.
It's regular, right?
It's a regular cosine as long as we have our highway lines. I'm not going to sleep tonight if I don't finish this. So here, let's do it. Midline, high cap, low cap. And since it's a cosine that has a positive number in front of it, we start high. So we're going to start up here. And we're going to go boop, 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 like that. So give me just a few more minutes of your life, maybe just a couple. Let me head over to Delta and just show you what this looks like. So take a look at this problem here. This, I think, is the exact same one we just did. How convenient. So what would be a good thing to scale my x-axis by? My y-axis, thank you, by 5. So I'm going to see, I don't know how much I can zoom. Oh, I can do quite a bit. So in this little box right here, I'm going to type 5. And now I hope you're paying attention. What was the final length of our period for this function? Just 4. So I'm going to type in 4, and I'm not going to touch the pi button next to it because I don't want it to be 4 pi. I just want it to be 4. And then I'm going to hit done, and it's going to it sets up my y-axis for me, and then it sets up this little blue dot. Watch as I move this around. I can drag this, and you'll see I'm going to drag it to wherever I want it to go here in just a minute. So ready? Here we go. Where did this graph start at? Do you remember what y number? Negative 20. So I'm going to make my first dot right here at negative 20. Click. And I know it's hard to see. And then where did the graph go? To the midline, which was downwards, correct? Now I'm choosing to skip a couple. If you're not listening, you're not going to get this tomorrow. I'm going to skip a couple. I'm going to skip like 1, 2, go to the third one, and then I'm going to go down. And where was my bottom at? My midline is negative 25. And then my next one, if I go 1, 2, 3, my next point was down at the bottom, right? And then I'm going to go across 1, 2, 3 to the midline, and then across 1, 2, 3 to here. And then all I need to do now is drag this 4 to right here. And the graph now knows what I'm saying. I'm saying my full period is from 0 to 4. And like I told you, notice we don't have to put the numbers in the middle. That's going to be a really big bonus for you. But that's what the graph can look like. And by the way, it can look completely different. Like if you had put these points further apart, you'd still get it right, provided that your 4 goes in the right place. If Layla just wanted to skip all the spacing and just go, just go 1 down and just keep going 1 across, down, 1 across, down, 1 across, up, her graph's going to look kind of squanchy, right? But she's still going to get it right. So that's what you're doing in this assignment, is you're really just mastering the art of like finding the new period and then putting points on the graph. What do you think of that? Can you handle that? We just got a lot done in 45 minutes. I just tortured the living daylights out of you. I will take the delta math off. I'll make it unavailable to you so you're not, because I know math can be really tempting, right? You're like, I got to do my math. I'll just take it off and I'll have it reassign itself tomorrow, and we'll just have tomorrow as a work day. Sound good? Deal? Good with me?
Sitting at home like that.
I know sometimes it's hard. You get to shakes and you're like, I got to do me some math. I get it. Hey,